Hey guys, this is our final lesson on Unit 4, and we're going to talk about the El Nino Southern Oscillation, otherwise known as El Nino and La Nina. Um, and that's just an image from a popular Saturday Night Live sketch with Chris Farley. If you have time, I suggest you go look it up. All right, so let's talk about the El Nino Southern Oscillation. This is this kind of cyclical recurring phenomenon that happens not necessarily on a regular schedule. So I can't tell you, oh, every 3 years is going to be an El Nino, and then every 5 years is going to be a La Nina. It varies. And honestly, you won't necessarily know which phase of this cycle we're in until we're in it and you're measuring sea surface temperatures. So these are characterized by different ocean surface temperatures in the Pacific Ocean, more specifically, kind of off the coast of South America, off the western coast, um, because the major effects are going to be off the coast of South America, which we'll see in a couple of maps. Um, these uh, these changes will cause global changes to rainfall, wind patterns, and ocean circulation patterns, which means they'll have a really big impact on weather and climate throughout the entire planet. And it's influenced by various geological and geographic factors. Let's take a look at this diagram. So this diagram is showing a kind of measurement that is used to help determine whether there was a La Nina or El Nino event in a year. Um, and you'll notice that everywhere you see that red shading, that means an El Nino was happening. Everywhere you see that blue shading, that means that a La Nina was happening. So some years you will have, like for example, here, it looks like there were consecutive years of La Nina. And here it looks like there were some consecutive years of El Nino. So it's not a super predictable pattern, at least not that we've been able to detect so far. By the way, if you're wondering where the name comes from, well, fishermen on the western coast of South America would notice differences in their fish catch, which has to do with the differences in ocean temperature, which we'll talk about in a moment. And it tended to happen around Christmas, so they named it El Nino after the Christ child, if that helps you remember this. So before we can go into what El Nino and La Nina do to the um, Pacific Ocean, let's talk about what normally happens. So, in normal conditions, there's a low pressure system over Australia that kind of draws winds, which are the southeast trade winds, to go from west to east. And this happens along the surface of the ocean. So you have this western blowing wind that is going to also influence the circulation of the ocean. So those trade winds are going to push surface water in the ocean towards Australia, which creates what's called the South Equatorial Current. Now, that causes an upwelling of cold water off the coast of South America. So, notice we have warm water being driven across the surface towards Australia, and that exposes colder water, which is able to come up. So, here you see some cold water off the coast of South America. Notice this thermocline, that is the difference, like a boundary with a major difference in temperature. Above that thermocline, you're going to have warmer water, and below the thermocline, you're going to have colder water. So as you push away the warm water, the cold water is exposed, and it happens to be nutrient rich. Remember, any water that's near the kind of base of a body of water is going to be able to pick up more nutrients because it's near the kind of sediment at the bottom, which tends to be more nutrient rich. So, what fishermen would notice is they'd get a better catch of fish in an El Nino year because fish will be able to grow larger populations because they'll have more nutrients available. But oh wait, no. Normally they'll get a good fish catch. Sorry, I bet. In an El Nino year, something different happens. The trade winds weaken. When that happens, you're going to have surface currents on the Pacific Ocean that are going to drive the surface water towards the east. That is going to cause reduced upwelling. So notice here the warm water and the cold water are separated by the thermocline, and the thermocline, instead of being up here, is down here, which means you're going to have much warmer temperatures off the coast of South America. So when you have warmer ocean surface temperatures than normal in the Pacific Ocean, that's an El Nino year. So notice there's less upwelling, there's going to be less nutrients, and so there's going to be also less fish to catch. That's, excuse me, what was noticed during an El Nino year. Hey, there aren't as many fish. We're not going to be able to catch enough fish to survive, and that's what first brought this to people's attention. But since then, we've got measurements. We can take measurements of the ocean temperature, and that's where that graph on the first slide came from. There is a reverse to this, which is a La Nina. And a La Nina is when you actually have um, stronger trade winds that are going to really blow warm water away from the west coast of South America. When that happens, notice your thermocline is now all the way up here with the warm water there and the cold water there. And so you actually have an increase in the kind of cold temperatures off the west coast of South America. So you have this stronger wind that's going to cause increased upwelling, and it's going to give you colder surface temperatures off the western coast of South America. So in general, an El Nino causes warmer ocean surface temperatures in the Pacific, and a La Nina causes the opposite, causes cooler surface ocean temperatures off the west coast of South America. And in general, for the most part, if you have one condition happen or one change happen in El Nino, you'll have the opposite effect happen during La Nina, which we'll talk about in a moment. So this is kind of a general graph showing you the changes in these general circulation patterns around the world. So the kind of convection currents. Here we have a rise in air with the high temperature air rising. It's going to cool down, and that's going to be where you see your precipitation. It flows, and then here is where you're going to have dry air sinking. So these are going to be drier conditions. These are going to be wetter conditions. Here you see dry air sinking as well. So here is going to be dry conditions. Here you have warm air rising. So this is going to be wet conditions. And I'll just complete up the circulation systems. There we go. So those are the convection currents. During a La Nina, you have warm air, sorry, not warm air, cool air sinking. It's going to be dry. So this is going to be extra dry. Normally kind of dry, but it's going to be even drier during a La Nina. Here you have warm air rising. So this is going to be wetter conditions. And then I'm just going to complete the circulation. Then here you also have warm air rising, which is going to lead to precipitation. So you're going to have increased precipitation in like Southeast Asia. In Sub-Saharan Africa, you should see some drier conditions because you're going to have cold air sinking and warming up, and it's going to have more evaporation happen than condensation. In general, there are some typical climate changes that are associated with El Nino. On the AP test, you'll see some questions about the United States, some questions about global effects as well. So I put a diagram here that emphasizes what's happening in the United States, but the descriptions are about what's happening throughout the world. So when an El Nino happens, you're going to have increased rainfall and flooding in the Eastern Pacific. And by the Eastern Pacific, I mean basically off the west coast of South America. Then there are droughts in Indonesia and Australia. You tend to have, at the higher latitudes of both the North and the South Hemisphere in North and South America, you tend to have more severe winter weather those years. Weaker monsoons in Southeast Asia and India, which can be a problem because they rely on those yearly seasonal monsoons to come in and drop a lot of water. You can have some increased rainfall in sub-Saharan Africa, which can be useful so that um, those people in those regions can grow more food. And then you tend to have weaker hurricanes in the Atlantic, but more cyclones in the Pacific. In general, hurricanes and cyclones are the same type of storm system. The difference is where they're located. I've seen in some definitions that hurricanes are in the Atlantic and cyclones are in the Pacific. Other places I've seen where they'll define a hurricane as happening in the northern hemisphere and a cyclone happening in the southern hemisphere. Just know that they're basically the same thing. La Nina will tend to have the opposite impacts. So you'll have a stronger monsoon in Southeast Asia and India than normal. Stronger monsoon you might think is better to bring more rain, but sometimes it can cause catastrophic flooding. There's also flooding in Australia, more rain in northern Brazil and southeastern Africa, less precipitation on the west coast of tropical South America, and also in the U.S. Gulf Coast and stronger hurricanes in the Atlantic, but fewer cyclones in the Pacific. Um, I have not found a really great way to memorize the uh, different effects that occur during El Nino and La Nina, but on the test, you will potentially see some questions asking you, okay, what are the effects of an El Nino in the South Pacific? What are the effects of La Nina in the southeastern United States? So I'll try to come up with, especially during review time, some sheets that will let you, or maps that will let you kind of work on memorizing where these effects happen. All right, that's it for Unit 4. Unit 5 notes hopefully will start going up next week.